Question 12b says simplify this. That's we have 2n squared minus 3n minus 2 over 2n squared plus 3n plus 1 times, on the upper part, n squared minus 1, n squared minus 4. When it says simplify, it's like solving a fraction question, but here we're having an algebra, and an algebra in a quadratic expression. So we have to cut down to the lowest term. That's just simply what the question is all about. It's like having 2 over 9 times 3 over 4. When you're cutting to the lowest term, 2 here 1, 2 here 2, 3 here 1, 3 here 3. So we have 1 times 1 is 1. Then you have 3 times 2, that's 6. So that's just what you're going to do, cancel out. But you can't just cancel out. You have to first factorize before you cancel out. And it's quite a technical question because you need an understanding of not just factorizing quadratic expressions, but identifying difference of two squares. So I'm looking at this question. There are two difference of two squares quadratic expression here. Here, the one on this side, the numerator on this side, and the denominator on this side. We've done similar questions as regards difference of two squares, where we have a squared minus b squared, meaning when you factorize, you have a plus b, a minus b. You have your n squared as your a squared, but what about the one at the back? Do you know that this is 2 squared? That's 2 times 2 is 4. Then this is 1 squared because 1 times 1 is 1. If you're not good at picking out difference of two squares, you have a problem with this question. We'll factorize this. We've been factorizing before, so this shouldn't be a problem. So we'll be solving simultaneously, not solving simultaneous question, but solving all of them as we go down. Let's start with this numerator. For this numerator, for us to factorize, since the coefficient of n squared is not 1, it's 2. Even if it's minus 1, you don't just throw it away or ignore it. You don't just ignore it. It's required to solve the question. But since it's 2, you do the 2 times the constant, which is not just 2 minus 2. You have to be very careful there. So you have 2 times minus 2, that's minus 4. Now we're looking for two numbers that will multiply to get minus 4. Yet when we add them, it gives us minus 3. So we know we've done this before, so we don't need to emphasize on the details. We know 2 times 2 will give you 4. When you subtract the two of them, it gives you 0. When you add the two of them, it gives you 4. It doesn't give you anything around 3, so you know it won't work. The next number that you multiply to give you 4 is 1 and 4. So you have 1 times 4 will give you 4. And if you add the two of them together, it gives you 5. If you subtract 4 from 1, not minding which one you put first, it will give you 3. So you know this will solve the question, because all you're looking for is two numbers you multiply to get minus 4. Yet when we add them together or join them together by addition, you get minus 3, ignoring the n. So how do you get minus 3? One of them has to get the negative, because we just done 4, and you have to get minus 4. So one of them gets the negative for you to get minus 4 when you multiply them together. So for you to get minus 4, yet you get minus 3. For you to get minus 3 when you join them together or add them together, that means for you to get negative 3, the bigger number would have to have the negative, while the smaller number takes the positive. That means you are owing more than you own, meaning we have minus 4 times 1. Minus 4 times 1 will give you minus 4. When you have minus 4 plus 1, when you add the two of them together, that's minus 4 plus 1. You're owing 4, you have 1. By the time you pay 1 out of the 4 you're owing, you still be owing 3. That's where you have minus 3. So that means we've broken down this minus 3n into two values, which is minus 4. You put n to it, minus 4n and plus 1n for the numerator. So you have 2n squared minus 4n plus n minus 2. That's for the first part. Then for the lower one, which is this one, this is also not 1. So you multiply the 2 by the constant, which is 1. 2 times 1 is 2. Now the only way you can get 2 is 2 times 1, and you need to get plus 3. So multiplying two of them will give you 2. That's multiplying this by this. The coefficient of the n squared by the 1 will give you 2. That's the one we use. So 2 times 1 will give you 2. Then 2 plus 1 or 1 plus 2 will give you 3. That means we don't have to solve too far. What we've done is just break down this 3n into two values that when we add them together, it gives us 3n. And when we multiply the two values, it gives us, not considering the n, although in school they will ask you to put into consideration the n. Well, since this is in a rough work, it doesn't really count as your step in solving the question. So we know the two values are 1 and 2. So we can choose to put any first. You still get the same answer. So we have 2n squared. You still repeat this 2n squared, but you've broken down this 3n into 1 and 2n. So we have it as plus n or plus 1n plus 2n plus 1. Now we've broken down into this times. Now let's create a difference of two squares here. So we have it as n squared minus 1 squared. Now considering this 1 squared is just the technicality you see in this question. It's still 1 squared is 1 times 1. It still gives you 1. So we're trying to create a way in which we can factorize this expression. So you have n squared minus 1, and below you see n squared minus 2 squared, because you know 4 is also 2 times 2, and 2 times 2 is 2 raised to the power 2. So we have 2 squared. Now we've created something we can work with. At this point, we group this in 2's and also this in 2's. So we have it as 2n squared minus 4n in brackets, then plus n minus 2 in brackets over 2n squared plus n in brackets, then plus 2n plus 1 in bracket, because this 2n owns this positive sign, so you put it in bracket. And on the other side, we have it as n squared minus 1 squared. That's a difference of 2 squared. So we have it as, we can factorize immediately, n plus 1, n minus 1. Then since we know this n squared minus 2 squared, when you see minus and you're having this one with the power of 2 and this one is the power of 2, that's the difference of 2 squared. So we'll have it as n plus 2, n minus 2. You take the n and the 2, ignoring the squared, and you add them together. In the second bracket, you subtract them. Now at this point, we look for what is common in these two and what is common in these two and bring them out. Now for the numerator, same for this. We've done this, we've factorized, we're factorizing this one. So for this one, we see that both of them have 2's and n's. This one has 2 n's, this one has 1 n. So we can bring out 2n. We know how to factorize. We don't need to dwell too much on that, so we can save time. So we have 2n squared and 2n. 2n squared divided by 2n. The 2 cancels the 2. There are 2 n's here. This n takes one of the n's here. You'll be left with 1 n. So we have it as n. Then minus 4n divided by 2n, or you can put the minus there first. Then you have 4n divided by 2n. The n's will cancel out. Then it's like this: 4n over 2n. The n's will cancel out. 2 here 1, 2 here 2. So we have it as 2. We close the bracket. For the second one, you can see plus n minus 2. There's nothing really common apart from 1. So you bring out 1. And since the n has a positive, you don't need to bring out minus 1. When it's positive, you just bring out plus 1. And when you bring out plus 1, it still remains n minus 2. And you see that these two values in the bracket are the same. Then you know you're on the right path, like I always said. So you will do it over. On the other side, we have 2n squared plus n. You know, both of them have n in them. Just only n. N on this side and n on this side. So bring out the n that is common. You'll be left with 2n squared divided by the n you've brought out. The n will cancel one of the n's, so you'll be left with 1n. You'll be left with 2n here. Then you have plus n. That's, you can put plus here, it doesn't affect the sign. So you have n divided by n. N over n will cancel out, like saying 2 over 2. That's 1. You have 1, you close your bracket. Now looking at this second one, there's nothing common in them. This is 2n and this is 1. And when there's nothing really common, or you don't see anything common, and there's no negative here, you just bring out plus 1. You open your bracket, you repeat everything inside. 2n plus 1. Close your bracket. Times. On this side, we still repeat all what we have here. You have n plus 1, close bracket, n minus 1, close bracket, over n plus 2, close bracket, n minus 2, close bracket. On this next line, like we do when we're solving a quadratic equation by factorization, when they are identical or the same, you pick one of them, then join this to this, the 2 outside. So you have n minus 2, close bracket, into open bracket, 2n plus 1. You join this 2n and this 1. Same applies to the denominator. Since they are the same, you pick one of them and put it in one bracket, then this n plus 1 in the second bracket. So we have it as 2n plus 1. You pick one of them, then you have n plus 1, close bracket. So you have this n plus this one joined together, times n plus 1, n minus 1 over n plus 2, n minus 2, close bracket. When you're done factorizing, you've gotten to this point, and they are all linked by times and they are in brackets. You can now start doing the normal cancelling. So you have n plus 1 here, n plus 1 here, you can cancel. That's the numerator to the denominator. The number above cancels the number below, or the number below cancels the number above. You have 2n plus 1 here, you have 2n plus 1 here, they can cancel out. This cancels this. Now what else can we cancel out? You have n minus 2 here, you have n minus 2 here at the numerator and the denominator. These ones also cancel out. Now we've cancelled out majority. What we're left with is n minus 1 and n plus 2 at the denominator. So we'll have it as n minus 1 over n plus 2, which is our final answer for question 12b.